So I'm still on this Kubernetes topic, and this lab that you're working on, there's a new section for this week. This section here on externalizing configuration. And when you've completed that, you'll need to submit it to Moodle for me. There is another section that I'm going to add on. I'll probably try and put it up actually later on this week. It's not a natural continuation from this stuff, but it's important that you look at the last section, which will be on ingress services. So on the slides, then, if we go back there, now I keep updating the slides every week. So if you are in the habit of downloading the slides, if you downloaded them a couple of weeks ago, then they're out of date. Really, you need to download them again. So what I want to look at today is application configuration. This slide is just talking about this area in general, and we know that it's a good idea just from a software engineering perspective. Um, it's a good idea to externalize any configuration settings for an application, so that you can use that application in different environments. And by environments, we mean kind of dev, test, QA, staging, production. These are all classically the different types of environments that we might want to run our application in. And there might be slight tweaks in those environments, which impact on the application's execution. And so rather than going into the code and making changes, we'd like to externalize them so that the code just picks them up from its environment at runtime. So we know all about that. The typical ways of passing in configuration data into an application is, you can do it from the command line when you start up the application, or in many cases, you can put the configuration data into an actual file, which the application is kind of hardwired to go looking for that file in a particular location. And so you just drop the file into the location and it picks it up. Thirdly, which is probably the one that we're most familiar with, is where you pass in configuration data via environment variables. When we're talking about Docker images specifically, uh, then there are actually two options available to us. We can actually pass command line arguments when we build an image. We had no use case for it in any of the Docker images that we were building, but you can do that, and you simply picked up those arguments. You can reference them in the Docker file. The one that we are familiar with is those at runtime. So sorry, these build time command line arguments, obviously they relate to the build stage of an image, as the name suggests. When you're running an image, in other words, when you're running a container, then you can pass environment variables. That's the way we know about how to configure an application, a containerized application at runtime. Um, that's fine. Now, moving into to our Kubernetes environment, we're talking about pod configuration. And we know now that I probably should have mentioned really that, so we've looked at pod manifests, at replica set manifests and deployment manifests. Well, the deployment is really the only one that you would ever use in real life. You'd never write a manifest file just for a pod or write a manifest file for a replica set. They're there, they exist, but they're very rarely used. So when I talk about pod configuration here, we're talking about configuring a pod within a deployment manifest. And equally, we try to avoid hard coding a pod's configuration within the manifest file for the same reasons as I mentioned kind of in the previous slide. And so what Kubernetes allows us to do is um, it provides what it actually calls volumes. We were looking at volumes last week, but there are these kind of special volumes that Kubernetes supports, which we typically use for passing in configuration data into a deployment manifest at kind of at deployment time. Yeah. Um, and the two manifests, these two kind of special volumes, even though we code the volumes, these special volumes in manifest files as well. Um, the two special volumes are called config maps and secrets. Okay. So if we look at config map first um, as a resource, we use the term resource as well in relation to Kubernetes. We've got deployment resources, pods are a resource, a replica set is a resource, a service is a resource, a volume is a resource, a persistent volume claim is a resource, etc., etc. So everything is a resource really. So we've got multiple kind of names for these entities. So config maps and secrets are two new types of resources, and we use them for um, storing configuration data, which can be then picked up by a, a pod at deployment time. So for config maps, I'm saying it's a Kubernetes resource that lets you store configuration data that can be reused. And the idea is that you might want to reuse that configuration data for multiple applications or even for the same application in different environments. Our configuration data is simply key value pairs, simple key value pairs. Now, what you can do as well, though, is uh, for certain applications that are running in a container within a pod, maybe that application, for example, Nginx, um, maybe that application uses a configuration file uh, for its own configuration rather than key value pairs. So how do we can actually pass a configuration file within these config map resources, and we can encode them in a YAML file. And you'll see a simple example of that in a while. So the configuration can either be simple key value pairs, or they can be an entire configuration file. Um, okay. When we are using these config map resources, there's a limitation on them. Okay, they can be no more than 1 MB in size. So if your configuration data is bigger than a megabyte, then you kind of have two options. You can use your more traditional volumes, which I was talking about last week, or you may even have a database that the application reads its configuration data from. The configuration data in a config map, you can declare it to be immutable. So once you've deployed the pod and it's picking up that configuration data, you cannot change it again, other than deleting the pod and recreating it. That's the only way, but you cannot change the configuration while the pod is kind of up and running. That's an option though, that's available to you. Okay, so let's look at a simple example. So in last week's lab, you would have created a MongoDB uh, 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 deployment, and that has a lot of configuration associated with it, like the admin. username and the admin password, for example. So let's suppose we want to store that kind of configuration data in a config map resource. So here we go. We've got yet another YAML file and the API version. Again, if you want to find out what is the API version, etc., it's the same way as before. Let's see. We can go OC API and grep for config map. Okay, so the API version is just v1. The short name for a config map is CM. Its kind is config map, right? And so looking at our sample here, yeah, we're using API version v1. Kind is config map. We have a metadata as we always do. The only one we're using is just the name for metadata. Now, sorry, am I looking at the right one? I am not looking at the right one. Oh yeah, sorry, I am, yeah. Here's the immutability option, which I've set to false. So I'm allowing myself to edit this and reapply it. Now, whereas most manifests have a spec property, you don't have a spec in the case of a config map. You have a data property. And here are essentially here's our configuration data. This is a simple key value pair, username, admin, password, secret. Here's an example where you actually are you want to pass in a file and make that file available to your pod. So again, the key can be anything, but I've just given the name to suggest that this is actually a file rather than a normal kind of key name, but it's still just a key name. I think you can really use anything here. It doesn't have to be the something dot something. It doesn't have to follow a file name format. The value though, we want this value to be interpreted as a multi-line uh, block, right? And the way you do that is by using this bar symbol. This is just YAML syntax now. So whenever you see the bar symbol, what follows is a collection of it's a multi-line block where the actual return characters or the new line characters are preserved and all of that. Yeah, so we'll see that actually, we'll use that later on, even though this is not configuration data. It's just text, but it could be anything, right? It could be JSON, it could be YAML itself. A lot of applications pick up their configuration by means of an external configuration file, which is also written in YAML. Nginx does, even MongoDB does, but we didn't bother using it. So that's our config map, and it's specifically for our Mongo database. So it's like any other manifest, we can just apply it. So let's do that. Apply or create. What do I call it? Mongo 02. And if I now go OC get CM is the short for config map. Here's my Mongo config. which is the name I gave it in my metadata. Uh, the other ones are just default config maps that were created when my account was created, so we needn't worry about those. And we can run the describe command, and we'll run it on. You can run the describe command on any type of resource. You've got to tell it what type of resource though. So CM for config map, and the name of my config map is this. Okay, so that kind of, when you look at it, that makes sense. These are the different data items, uh, etc. down here, so that all adds up. So that's fine. My config map resource is now created within the Kubernetes cluster. And so that this will be stored in the etcd database, which you might remember. So if we now look at our deployment manifest for our Mongo image, and the only thing that's different now is if we pull this down a little bit, how do we refer to our config map key value pairs? So let's see. Here's how we do it here. So here's uh, the root password, and previously we just had value here, but now it's value from. It's value from, and then we tell it that it's coming from a config map key reference. Here we're giving it the particular key within our config map, and here we're telling it what is the name of the config map that contains this key that we're interested in. So that's just the syntax. Value from, etc. Similarly for the username. So that's pretty straightforward. Now, the other entry we had in our config map was the configuration file. Yeah. Now that's treated as a. Oh, do I have both of them open? Let's go back to 02. Okay, so we've seen how to reference these within our deployment file. How do we reference this kind of block, which is essentially representing a file? Well, you you reference that as a normal kind of volume using the kind of volume syntax that we looked at last week. So if we go scroll down to the volumes part of our deployment, this was what we had last week, the persistent volume claim, which is storing our actual database data. But here's where we're referring to the config map special volume. Okay, so the name, this is whatever name I want to give to this volume. Uh, this is telling us now that it's a config map volume rather than a persistent volume claim type of volume. Uh, what is the name of the config map? That's what you're specifying here. And the rest then is we have to tell it which items within the config map are we interested in. And in our case, it was the item or the key called mongodb.config. Sorry, now just want to get something out of my way in the. Where is it? Yeah, mongodb.config. That's the particular item that we essentially want to mount it as a volume. And okay, that's that's item, the item key. And with all volumes, we have to indicate where within our container should the volume be mounted, which is the path property. Yeah. So we're saying here that we want it to be mounted. Uh, sorry, no, I left something out there. If I go back to here, sorry, this is where we're this is where we're referring to the volume, and we're telling it that we want the volume to be mounted at this location, at this path within our container. So there better be a directory called bitnami within our container, and there will be, because we're using the bitnami MongoDB image, and it does create a directory called bitnami, which is a subdirectory of the root. So we want the volume to be mounted at that particular path within the container. What I'm doing down here then in the path is essentially kind of extending that. Where exactly within the bitnami folder do I want it to be mounted? So the upshot of all of this is that there should be a file called test.config that should be in the bitnami folder within my image at runtime. And the contents of that test.config will be, that keeps getting me, sorry, will be this data here. Okay, so let's just actually kick off or deploy my MongoDB. And if I go OC get pods, there's my Mongo pod created by the actual deployment. Now, if I just if I exec into that, I'm now inside a container. If I list my environment variables, and hopefully there should be an environment variable for the root username and root password. So here's the root username, admin. So that seemed to have been picked up correctly, and the password is somewhere as well. Is it staring me in the face? Can I find it? there. So I picked up both of those correctly. And the other thing was the actual file that was mounted. And I wanted it mounted. So if I do a ls on slash bitnami, there's my test.config. And if I cat that, then it has the contents from my config map. So that all seemed to work fine. Now let's supposing I want to change my, let's say my uh, admin password. So I go back to my config map resource and I'll change the password to, uh, let's go pass 1234. I need to reapply or update this resource in the cluster. And I can do this because I did set the immutability property to false. Okay. Now, if I go back into my image, uh, yeah, and I go env, where is my root? These are always difficult to find. There's too many of them there. Where is it? Go. Oh yeah, see here, it actually hasn't changed it. And that is, as you know, environment variables they are initialized um, at container startup, I suppose, really is what is how you might put it. Uh, so we actually need to ensure that the container is restarted in order for it to pick up the updated environment variable settings. And the simplest way to do that is to just delete the pod. And we know the pod will be recreated because of that self-healing idea. So if we go OC delete pod, and the pod will be recreated. So we now need to exec into this. pod. We go env again. Hopefully I can see it quicker this time. Gets me every time. I can never find it. Gosh, there we go. Oh, hang on. Why did it not pick it up? That should be... What's going wrong there now? Let's see. Not what I expected. Let's exit out of that. Let's OC get CM. Scribe CM. That should be 1, 2, 3, 4. Past 1, 2, 3, 4. Did the application not work? OC apply minus F02. Okay. I mustn't have applied it properly. So what do I need to do now? I need to delete my pod again. Pod has been recreated, hopefully. And OC exec. going to cheat this time and I'm going to pipe that into grep. Didn't work. Oh, where's my password? There we go. Okay, so it's picked it up this time. That was a struggle. All right, so and the file is still there. That hasn't changed. So that's so what have we done? We have demonstrated creating a config map and picking up that config map within my deployment manifest. Okay. Uh, the other type of configuration resource is what are called a secret. And as its name suggests, that is used if you've got configuration data that is confidential. Yeah. Um, a secret resource in terms of the manifest file, it's actually identical to a config map, except it has a different kind. And the other thing that you need to do is so your data within a secret are again going to be key value pairs. You don't tend to have config files as secrets that tend to be just standard key value pairs, but the value has to be base 64 encoded. And as you probably know, if you want to get the base 64 encoded equivalent of any kind of piece of text, this is how you can do it from the command line. So if we wanted to, let's say, if I go echo to exit out of this, if I go echo minus n, you need the minus n, pass 1, 2, 3, 4, 5, pipe that into base 64. Okay, and if I go away and create a secret manifest file for myself, and I've got one here, and again, the structure is the exact same: API version, kind, metadata, and just data. Am I looking at the right one? I'm not. It has the immutability property. Oh yeah, it has a type property as well, which, as far as we are concerned, the type is always opaque. There is another type, but it doesn't apply to us. And on the data side, then, uh, password is the only secret that we are interested in encoding. So if I just grab this value down here, paste it in here, I apply my manifest. So if I go OC apply minus F, and it's 0.4. OC describe, OC get first, I guess. OC get. Again, there are some default ones, but the one that I've just created is this one here. And the describe works on it as well, and its output is similar to the output for a config map. Now, to go back to my Mongo deployment, the way we refer to a secret is very similar to a config map. And let's see. So here it's just, we just use this instead of config map key ref. So if I change that to that, and again the key is password, and in this case the secret manifest was called Mongo secret in my case. Is that right? Let's just check that again. Yeah, the name was Mongo secret, so that's okay. Now, because I've made changes to the actual, can I? It's probably safer now for me just to delete the old deployment. OC delete. Deploy is short for deployment, and the name of the deployment is that. I could have done an update, but I'm not certain whether that would work or not. Let's recreate my deployment. OC get the pod and exec into it. See if it picked up the secret password. Here's the bit I don't like doing, env. Here we go again, struggle to try and find it. Oh, there we go. Pass 1, 2, 3, 4, 5. So it seemed to pick it up fine. Okay, so that's secrets and config maps, and it's just a way of externalizing your deployment configuration data. And in this week's lab, that's essentially what you're doing in the very last section. If I go back and go to here, the last section is externalizing configuration. So you can work your way through that, and if you'll see at the very end of this section, you need to submit it up to Moodle for correction, for assessment. Now, in terms of the assignment that you submitted, I'm planning to assess those this week, so hopefully I'll have results for you. I might have them by the end of the week. If not, I'll certainly have them for next Monday. That's the plan. And in terms of, what I need to cover with you, really the only thing I need to cover is these ingress services, and that's going to be that'll be very quick, really, to cover that. I could do it tomorrow morning. I'll either do it tomorrow morning or next Monday. Either way, it'll be very short, and then we're finished, really. I won't cover any more material. Now, of course, there is a lab-based exam in week 13, and I will give you lots of information on that exam probably next week, really. I haven't really set it yet, so I need to sit down and set it. And when I've set the exam, then I'll be able to give you hopefully some good briefing on it before you actually sit the exam. Okay, that's it for me. I'll pause just in case there are any questions from you. No. All right. I'll talk to you tomorrow, either over Zoom or via Slack. I'll let you know. Thanks. Bye bye.